Now, please welcome President, Product and Business, Weil.
All right, that was amazing. Hello, everybody. We're going to spend the next 30 minutes going deeper into our strategy and roadmap, and we've got a lot of exciting things to show you. Before I do, though, let me briefly zoom out. I look at my role as president as three things. First is guiding our product strategy and execution. Second is building a tight loop between you and Planet, between the feedback that you give us and using that to make our products better. And third, it's bringing world-class talent to Planet so that we can evolve what we do to better serve you. And speaking of world-class talent, I'm really excited for you to meet some of my colleagues. They'll give you some deep dives. Tara, Alev, and Justin will be out in just a few minutes. So I have this poster that hangs in my office at home. And it says in big red letters on a white background, good work, consistently, over a long period of time. And that to me is what delivering for customers and partners is all about. Our strategy sets our general direction, and then we put our heads down and execute. And as we do, we pay close attention to data and to customer feedback. We're not perfect yet, but I'm thrilled about how customer-driven Planet is becoming and how much momentum that we're building. Case in point, what you'll see on the next few slides is just a sample of the improvements that we've made for customers and partners this year. Not all of these make the front page of the news. In fact, most of them don't. But every single one of them is a big deal to us. And the best part about doing this kind of foundational work is that it doesn't only improve our product, it improves every downstream model and decision and analysis that you all do that our products power. So first, we upgraded our entire PlanetScope product from 4 bands to 8 bands, which has opened up new use cases in environmental monitoring, coastal areas, and more. As we did that, we massively improved band alignment across all of our imagery, meaning from one day to the next, our imagery got visually and radiometrically sharper. And latency has come down dramatically. We now downlink, process, and publish our entire capture of the Earth every day within about 15 hours, enabling you to see change and make decisions faster. And we launched 36 new SuperDoves at the beginning of the year, 80 new satellites in total since the last Explore. On the SkySat front, we've massively increased the capacity and efficiency of our SkySat constellation, which means your collects come faster, and there's more to come on that front. We've also reduced the latency of our SkySat pipeline, so assured collects are typically available now within 5 hours of collection, and we're going to keep driving that number lower. Our tasking dashboard provides better transparency into weather and other parameters, and customers with many simultaneous tasking orders can manage them more efficiently thanks to continuous UI upgrades. And we completely rebuilt our analytics pipelines, making them faster and more accurate. Our ship detection models now extend further out into open water. We boosted outlier detection and increased the sensitivity of our soil water content, land surface temperature, and biomass proxy planetary variables. And we're hard at work now upgrading our cloud masks. We'll have more on that soon. On the platform side, we're making weekly improvements to our account management and quota systems. These are small but important changes that make all of your lives easier. We've upgraded our GIS integrations, so you can do more with Planet data from within Esri and QGIS and Google Earth Engine. We've integrated Planet base maps into the Orders API. And as Will announced earlier, we're just about finished with the integration of Vandersat's planetary variables into our core subscriptions API, including time series and summary statistics. And these improvements are making a difference. And it's not just products, by the way. We've also invested significantly in our customer success and customer support teams to better serve you. And collectively over the past year, our Net Promoter Score, as judged by all of you, has risen 24 points from 38 to 62. So let me turn now to where we're going next. Those who know me know I'm relatively new to this industry. Prior to coming to Planet, I was head of product at Twitter and head of product at Instagram. But actually, surprisingly, there are a lot of similarities between those places and Planet. For example, it's all about building customer-driven products. We're looking to simplify a complex experience to help our users get value quickly. And third, even the use of AI, which touches every single pixel of Twitter and Instagram, is now starting to be everywhere at Planet too. People often ask me what drew me to Planet, and my immediate answer is always the mission. I've always been a mission-driven person, and as Brad just said, our ability to image the entire Earth every day is fundamentally a new capability for humanity. And I think Planet can be a generational company, and that between all of us in this room, our potential customers go well beyond the traditional geospatial industry and include basically every company and every country in the world. But it all starts with our mission. We image the whole planet every single day and make change visible, accessible, and actionable. Those last three words are key. We're going to talk through them: visible, accessible, and actionable. Making change visible is all about our unique Agile aerospace capabilities. Planet builds satellites smaller, faster, and more cost-effectively than anyone, and that's what allows us to build large, disaggregated constellations in space. It starts with our SuperDove constellation, roughly 180 satellites, imaging the entire world every day in 8 bands at 3 to 4 meter resolution. They generate a unique data set documenting daily change across the planet, something that's never existed before. But it's not just about one day's worth of data. We now have an archive that has over 2,400 days of history over every single point on Earth. And then we have SkySat, our tasked constellation of 21 satellites that image at 50 centimeter resolution with the ability to see a given point on Earth up to 10 times per day. Now, you heard Will talk about the Chinese balloon. Before this balloon burst into our lives a couple months ago, how many people knew to go looking for it? Nobody? We didn't either. But that's the magic of having a 2,400-day archive of the planet, especially when you combine it with the revolution that's happening in AI. Our partner Synthetic has built a broad area search product, and we worked with them to find the balloon, not once and not twice, but 9 times. And we traced its path backward across the US, into Canada, into Alaska, across the Pacific, and back to Hainan in the South China Sea, where we caught it just after launch. We didn't know to look for the balloon before, but our data makes it possible to travel back in time and look for anything. Now imagine applying this to our entire archive. Imagine being able to answer questions like, have there been any other Chinese balloons? How many of them? Where did they launch from? When did they launch? Where did each one go, and what did they look at? And then imagine applying that same search, but not looking backwards, looking forwards, proactively, scanning each new day's imagery as it comes in, so you're immediately notified whenever there's a new balloon launch from anywhere in the world. And now imagine replacing the notifications for a newly launched balloon with anything that you want to track. New weapons silos, or well pads, or wheat harvests, or Uyghur camps. This is possible today with Planet's imagery and archive and with AI from our partner Synthetic. But we're not stopping there. We know that one of the challenges with any satellite data is the inherent noise. You have atmospheric interference, you have clouds, you have radiometry. And getting to a consistent time series is one of the keys to unlocking insights, but it takes major work. That's why we're working on a new analysis-ready It'll be radiometrically harmonized using Landsat, Sentinel, MODIS, and VIIRS. And it'll all be co-registered for easy time series analysis. So if you're doing temporal analysis, analytical modeling, change detection on PlanetScope, this is the product for you. We're working on perfecting it right now with a small number of customers before launching it more broadly. And when it launches, it'll be an intermediate product between PlanetScope scenes on the one side and our Fusion product on the other, which includes all of this, plus gap filling, temporal smoothing, and predictive modeling. So that's some of the work that we're doing with our current constellations. I want to switch gears now and talk about the new constellations that we're building. Pelican here is our upgrade to SkySat, and it's going to be better in every way. What do I mean by better in every way? Well, instead of 21 satellites, the Pelican constellation is planned to be about 30, so about 50% bigger. Instead of 50 centimeter imagery, Pelican will produce 30 centimeter imagery. Instead of 10 revisits to a given area per day, Pelicans plan to do up to 30 revisits in many areas. That is, a revisit every 30 minutes. So 30, 30, 30, 30. 30 satellites with 30 centimeter imagery, 30 captures per day, one every 30 minutes. And that's not even mentioning a host of other awesome features that Pelican will have. Pelicans will be able to connect to satellite communications constellations, which means they'll be able to do real-time tasking and data downlink. Plus, they'll have onboard compute, so we can run algorithms on the satellite in space. They'll be able to capture video and more. So how does this play out in practice? Well, imagine that you're in national security and you get a tip from a source, or maybe you're monitoring the Amazon and our new analytics just highlighted there's a new road being built. You want to dig in and understand it. Say it's 2 p.m. and you use Planet's tasking API to submit a task right at 2 p.m. That task is immediately uplinked to a Pelican in space. And by 2:17, there's a Pelican over your area of interest. It collects the image and immediately downlinks it through a SATCOM constellation. By 2:42, the image has been processed, and by 2:47, it's been uploaded to a cloud bucket that you own. So in under an hour, you went from a tip to having 30 centimeter imagery of a point on the other side of a planet. That's the kind of thing that is possible with Pelican. And we're going to be launching the first tech demo later this year. We're also simultaneously building out Tanager, our new hyperspectral constellation. And with Tanager, we move beyond the optical spectrum to hyperspectral data. So not 8 bands in the visible and near infrared, but 400 highly precise 5 nanometer bands that go from the visible spectrum through the near infrared, through the shortwave infrared, all the way out to 2500 nanometers. With 400 spectral bands, you basically can think of these satellites as detecting chemical signatures, which is exactly the driving use case. Tanager is designed to detect and locate 90% of methane and CO2 emitters. Measuring methane and CO2 globally will provide the world ground truth, a new important kind of ground truth, as well as an ability to hold governments to their promises and to hold big emitters accountable. But these satellites will be able to see far more, including applications in mining, biodiversity, environmental assessment, and natural resource management, as well as in defense, where you can use them to detect a variety of chemical and material signatures. When you take these together, Tanager and Pelican are going to provide Planet and our customers and our partners with unprecedented data, all coming very soon. But we're not stopping at just producing new data sets. The even bigger opportunity is in moving up the stack from imagery and data to APIs and machine learning and time series. We're building new derived data sets on top of our core data, layers that you can mix and match together like Lego blocks that provide new capabilities, that extract new insights, and that generally just make our data more valuable and easier to use. Each of the icons that you see here and that you're going to see as we go through these slides represents a single example of a data or of a service at each layer. So here you see our PlanetScope monitoring, you see high-res tasking, a la SkySat and Pelican, you see Tanager, and you see our billion image archive at the very bottom at the sensor layer. As we go up though, we have 30 terabytes of raw data coming in every day. We have to move beyond humans looking with their eyeballs at imagery. The future is about computers fusing multiple data sources, running algorithms to automatically identify objects and patterns and time series. Over the last year, we've begun to build more sophisticated building blocks that we call planetary variables. And as we do, notice that these products don't look a lot like imagery. They start to look more like a matrix or a time series, something that anybody who knows how to use Excel can use. We want to see geospatial analysis and data go mainstream because it's going to benefit all of us. And we're making real progress here, as Tara is going to show you in a second. And we call these building blocks because they are. For example, at the insights level, you can combine planetary variables to produce accurate estimates of crop yields. In fact, last fall, Bloomberg published our crop yield estimates in the Bloomberg terminal a few days before the official USDA crop yields report. And Planet is not going to build all of this. It's going to be an ecosystem-wide effort. We want to create some of the core building blocks so that we make the rest easier and faster and more accurate. But this is a pyramid that we're all going to fill out together for the benefit of our collective customers. Because every bit that we move up the data pyramid, we're making it simpler to integrate and use Planet data and allowing you, our customers and partners, to spend less time recreating the wheel and more time where you uniquely add value. So with this framework in the back of your minds, I'd like to pass to my colleague Tara to speak more about our planetary variables and show some examples of how customers and partners are using them today. So please join me in welcoming Tara O'Shea, Planet's Senior Director of Forests and Land Use.
Awesome. Thank you, Kevin. All right, good morning. So I am excited today to share a bit more about our planetary variables product line, as well as just a couple of the partner and market opportunities that we see. So for those who are not familiar, planetary variables draw on observations from multiple sensors in order to continuously measure changing conditions in an automated and scientifically validated way. Products like soil water content, land surface temperature, and crop biomass are available today through Planet's platform and APIs, as Kevin mentioned. With products like forest structure, forest carbon, and vegetation encroachment becoming available later this year. So as Kevin just said, we are going up the data pyramid so that you can start there, reducing workflow friction and time to value for our partners and customers so that we as an ecosystem can open new markets and bring geospatial insights into a range of applications. Because we know that's critical, as Will said as well, to the sustainability, security, and digital transformations that we're all here to discuss over the next couple of days. So what does this mean in practice really, right? What's it mean to go up the data pyramid or to bring geospatial insights to new markets that have not really been able to harness them in the past? Well, let's take that drought index insurance example. So previously, farmers have faced a lot of risk when it comes to drought and soil moisture. But now, with the soil moisture content planetary variable available globally, we can accurately and cost-effectively measure that risk. And that means we can better manage those risks with tools like insurance. So together with our partners at Swiss Re and AXA Climate, this variable product is now informing drought index insurance services in 28 countries around the world. And in practice, that means more sustainable and resilient food systems and more equity for farmers. So you can imagine, what if we could do the same with measuring things like forest structure and forest carbon? What if, by combining data from multiple sensors, like PlanetScope and LiDAR, we could move up the data pyramid from imagery to automated insights on forest structure, like canopy cover and tree height, all the way through to accurate automated insights on above ground forest carbon? What might that sort of capability mean for measuring and managing risks in new applications and new markets? By working with partners, these forest structure variables can, as just one example, better inform models of wildfire risk. And again, if we can better measure that risk, we can better manage it. So for example, in California, where I live, I think many of us in this room probably live in California, it is really critical that structures in wildfire risk area have a certain amount of defensible space, free from vegetation. Well, the California Air Resources Board, the regulatory agency in that state, was able to use these variable products to check over 2.5 million structures for defensible space requirements in an automated and cost-effective way. So again, imagine what that sort of capability might mean for new markets, like insurance. So we're really excited to bring these sorts of services to market with our partners as these forest variable products come online later this year. And so again, as I summarize just a couple of the market opportunities and the partner opportunities that we see and that we're excited about with planetary variables, I want to bring it back to Planet's core mantra. And I think you heard it in Will's remarks, you heard it in Kevin's remarks. You can't fix what you can't see, or you can't manage what you can't measure. We believe this is at the root of many of our current sustainability and security challenges. And it's the piece of the puzzle that we are trying to help solve by working with our partners around the world. The launch of planetary variables is the next and important step in that work. So again, as Kevin said, our goal is to make geospatial data easier to use and shorten your time to value so that we as an ecosystem can open new markets and bring these geospatial insights into a range of applications, because that is how we are going to better account for and manage today's risks. And so just as you can't fix what you can't see, with that huge archive that Kevin mentioned, we've also realized you can't fix what you can't find. So I'm really excited to welcome to the stage my colleagues Justin and Alev, who are going to share more with you about what Planet is up to in change detection and analytics. So please join me in welcoming Justin and Alev.
All right. Thank you. You too. You too.
Thank you, Tara. My name is Alev, and I'm a product manager for tasking.
And I'm Justin, a product manager for our planetary variables.
And we're here to talk to you about how we're making it easier than ever to find change across our world and see that change in stunning detail. Let's take a look at a real-life example of how we can orchestrate our capabilities in practice. Deforestation is a topic dear to our hearts. In fact, 40 football fields of forest are lost every single minute. In the time since this presentation started, it has already been 420 hectares. This is a problem that concerns all of us, the entire planet. The changes are rapid, and the area to monitor across the world is so huge that this is an immense effort. Let's take a look at one deforestation example in Colombia. Zooming out, you could see just how difficult it would be to find this manually through time.
Right, there's just so much of the world to keep up with. And while PlanetScope is capturing just about all of it each day, us humans that have to parse through all of that imagery can have a really tough time finding what it is we're looking for. And as we've discussed, AI is having a bit of a moment these days, where just about every industry is trying to figure out the best ways they can use it to make their customers' lives easier, and Planet is no exception. So we're using computer vision and AI to automatically find new development, like roads, which can lead to or indicate deforestation. Like in this example, roads that exist under tree canopies become visible when those trees are cleared away. Our models can help point you to where that change is taking place. Now, it's one thing to find areas of change across a city or county, but where the service really shines is with its scale. For example, here you can see where new development is happening across the 9 million square kilometers of Brazil. And this is refreshed on a weekly basis, helping shine a light on areas that were previously